Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 12 of the February daily LeetCode challenge and we are almost reaching the mid of this month and now the gear is changing. So till now what you have seen, let me remind you, first 5 days we saw questions on arrays, they were all easy questions. After that we saw some good questions on hashMap, they were also really good. From the last 2 days we were seeing questions on the topic of stack. Okay, they were easy and medium level questions. That those are, I will say, like easy and medium, like the way as I told, like they're exactly the same. And now from today onwards again the gear is changing and today again we are back to hash maps. So this question is going to be on hash map topic. So after seeing some question stack, this is the next level of the questions. Okay, now today it is 2342, maximum sum of a pair with equal sum of digits. Okay, it's a very good question basically to begin with. And see, the aim in this kind of question should be how fast you're able to do it, at the same time how much of like the solution is beating how many times other solutions. Okay, if you see here, my solution is beating around 99% of that is cases. That's what actually matters in this kind of questions, because see, there are multiple ways to solve it. Okay, you can even solve it using brute force, that will also work. Okay, there are other ways also, I will tell you that how it works, what are the brute force way of doing it. But again, it all matters is how efficient your code is. Okay, in these kind of questions. Now coming to this question, see here, we are basically given an integer array called nums. Okay, it's all going to be positive. You're given a zero indexed array nums consisting of positive integers. You can choose two indexes I and j such that I is not equal to j. That's the first condition. See, here they're talking about indexes. Remember, I and j are indexes. So they're just saying like you cannot form a pair of a number with itself. Okay, as simple as that. That is, a single index cannot form a pair with itself, right? And the sum of digits of the numbers nums I is equal to that of nums j. Okay, see, this part is something that I don't think we have seen from a long time. Okay, after a long time we are getting a question on this. See, what they're talking about is the sum of digits. Okay, it's not about, see, they're not talking about sum of the numbers, they are saying sum of the digits. Okay, if, see, I and j are two indexes, right? First condition is that I should not be equal to j, that is the number should not be same. Okay, next condition is that the sum of the digits, okay, of the number nums I is equal to that of nums j, that is nums I and nums j. Okay, if you take those two numbers and add their sum of digits, they should be same. Okay, we'll take example now, we'll try to understand that. But just remember, there are the two cases. Return the maximum value of nums I plus nums j that you can obtain over all possible indexes I and j that satisfy the conditions. Okay, so first we'll try to understand what are the conditions and which, like we'll say example of a pair satisfying these conditions. Okay, for example, see this case, let us talk about this. Okay, it is 1 and 18. Okay, so if you take the sum of digits of 18, it is going to be 1 plus 8, which is equal to 9. Okay, similarly, if you take 3 and 6, it is going to be 3 plus 6, which is 9. Okay, that means this particular value and this particular value, the sum of digits is the same. Okay, so they satisfy these conditions. Okay, I is not equal to j, at the same time the sum of digits is same. So in this case, one possible answer that we are getting is this. Okay, 36 plus 18. Okay, because remember, we have written the maximum value of nums plus nums j. Okay, whichever I and j satisfy these conditions, we will have to take the sum of them. Okay, and we have to return the maximum sum. Okay, so 118 plus 36 is going to be one possible answer, but we'll have to again check whether there is another pair which has a higher sum than that or not. Okay, I will show you, like in my tracing, I will show you that. But just try to understand this question. It is going to be 18 plus 36. Okay, it is one of the possible answers. The other possible answer could be, for example, here it is 4 plus 3, 7, and this is also 7. So this also could be a possible pair. So 43 plus 7 is going to be the next possible answer. Okay, and yep, that is all right. See, 13 is 1 plus 3 is 4. It is not forming a pair with anything else. Okay, so this should not be taken while calculating the answer. Remember, as that's why they have mentioned. See, if you have a single number, okay, which is not forming a pair with any other number, in that case you cannot take that number as your answer. Remember that part very keenly. Okay, and yeah, one more thing is, you will have to return -1 also. See, they have not mentioned this in the question. Okay, they have not mentioned anywhere in the question. Okay, which is not a good thing according to me. So but if you come to example number 2, they are clearly mentioning that there are no two numbers that satisfy the condition, so we return -1. But they have not mentioned anywhere in the question that we have to return -1. Okay, that is not something good. I will say LeetCode should improve on these things. Okay, as simple as that. So but yeah, just remember one thing, you have to see, this part is important, because though they have not mentioned the question, still you are expected to return -1, otherwise you will be failing some of the test cases. Okay, so if yeah, okay, let me quickly show you the tracing output so it will make more sense. See what is happening now. If you talk about example number, okay, let us go step by step. Let us go to example number 1 first. Okay, so for the sum 9, okay, for the sum of digits equal to 9, what are the pairs? It is going to be 36 and 18. Okay, if you see them, these two are, if you take the sum of the digits of these two, it is getting 9. So these two will form a pair. Okay, so sum of these two is going to be one of the possible answers. Similarly, 7, if you take the sum of digits equal to 7, there are two numbers which are having that. Okay, 43 and 7 itself. Okay, yep. So if you take the sum of these two, that is again going to be a possible answer. But remember, among all such possible answers, you will have to return the maximum possible answer. Okay, yep. Yep. And finally 13. Okay, if you see 13 is not forming a pair with anything else, why it is coming minus 14, I will explain that. That is a, I will say like a workaround that I have done. Okay, I will explain how that is coming. But yeah, just remember, as I mentioned, like see, all the numbers are going to be positive. Okay, so whenever you're seeing a negative number, just understand that this particular number 13 is not forming a pair with anything else. That's why you have written a negative number here. Okay, why I've written minus 14, I will let you know that. But again, just know this part. Okay, whenever you see a negative number, that means that the other number is not forming a pair with anything else. Okay, so let us quickly go to the code now. So first of all, in this, if you have to break this problem into two parts, first one is going to be how to get this sum of the digits for a number. Okay, we'll come to that. So for that reason, I have formed this particular function. Okay, I want to break it into functions so that we divide the functionality. See, whenever you're doing a code, no, let it be in an interview or even when you are, once you are getting selected in a company and you're doing the code, always remember it's all about how much you are able to divide the code into smaller functionalities so that they are reusable. Okay, and I've done the same part here. If you see, this function is going to return the sum of the digits of that particular value. Okay, so I will pass the value here. Okay, what is happening next? See, this algorithm, I'm sure that you will be knowing. This is a very basic thing. When you enter, let us say, engineering or any programming language course, you will learn these things first. Okay, see, while value is not equal to 0, this thing will continue. What is it? First, we are dividing, like we are taking a modulo. Okay, we are taking a modulo 10. See, for example, I hope you are knowing this, but yeah, just if you are not aware, let me just tell you that. So for example, you are having 376. Okay, so first digit is going to be 6. I want the digit 6 first. Okay, so how to get it? So when you do a modulo with 10, okay, what is modulo? Modulo means remainder. So when you divide it by 10, what is happening? You will get 38. Okay, 38.6, right? But don't consider 6. I just want the integer division part. Okay, you are going, so quotient will be 38 and remainder will be 6. So when you're doing a modulo, the remainder will be sent. So the remainder of this is going to be 6 in this case. Okay, so 6 will be added to the sum. Okay, the first digit will get a 6. So now we want to remove the 6. So what we'll do? Now we will restore val to be the quotient of val integer divided by 10. Okay, that is, see, we have taken the remainder 6. Okay, next we want to eliminate the 6. How to do that? If we can do this. Okay, for example, say 386. Okay, integer division by 10. What is integer division by 10? It will basically return 38. Okay, integer division means, see, I want the quotient in this case now. Okay, previously we did the remainder, now I want the quotient. Okay, what is the quotient? Like, see, just go and see what is it. Like, see, there are four things here: divisor, dividend, quotient, and remainder. Okay, before you, if you do this particular operator, this will give you the remainder. If you do this operator, this is basically division operator, this will give you the quotient. Okay, always the quotient is written. Okay, it is the integer division operator, so we want the integer part of the dividend. Okay, sorry, the quotient. So in this case it will return 38. Okay, this will return 38. So we are able to eliminate 6. Okay, now we are able to eliminate 6. So see, here we took the remainder, the last, that is, you can say the, I can say, least significant bit, least significant digit, you took the value. After that, you removed that by taking the quotient. Okay, now val is equal to the quotient of the previous value. Okay, as simple as that, division by 10. Okay, fine. This will keep continuing till the value is not equal to 0. After that, we return the sum. Okay, I've tried to explain the best, but yeah, see, these things are very basic. That's why I'm not spending much time. But yeah, if you're not aware, take this function out, try with some certain inputs, add some print statements, and then go through it, and then I'm sure that you will be able to understand it. Okay, since this is very basic, I'm not taking much time here. Okay, now, as you know, this is a hashMap question. So why the hash was needed? See, it's very clear. For each, see, the key is going to be the sum of the digit. Okay, so whichever digits, whichever numbers are having a particular sum of digit, that is going to be the key. Okay, so for example, 9 is the key, means there are certain numbers whose digit sum is equal to 9. Okay, so for all of them, we will be storing it for this key. Okay, what is the value going to be? The value is going to be list with two numbers. Okay, remember, it's not like in this case only two numbers are, so I written two. It's not like that. Always I'm going to store only two numbers. Okay, if there are more than two numbers which have the sum is equal to 9, still I will be storing only the topmost two numbers. So topmost in the sense highest two numbers. Okay, because remember, we want the maximum sum, so I only need the highest two numbers which have sum is equal to 9 in this case. Okay, other numbers I will not store because that is not efficient thing. Remember, if you have to get this kind of time complexity runtime, you will have to optimize in every way possible. Okay, that is one such optimization that I'm talking about. Okay, here if you see, I'm only storing the highest two digits which whose sum is equal to 9, sum of is equal to 9. Okay, as simple as that. So let me show in the code part now. Yeah, this is going to be for that. Okay, the key is going to be the sum of digits, the value is going to be a list with two numbers. Okay, now I'm going through every nums. Okay, that is, I'm going through every element in this particular input. Okay, now First of all, I'm getting the sum of digits for that particular number. Okay, for example, I will start with 18, we'll go till 7. For 18, for let us say I'm going to call this function, this will give me the value 9, because 8 plus 1 equal to 9, so this will give me 9. So here sum is equal to 9 now. Okay, now I'm just checking whether this 9 is a key here or not. Okay, if this 9 is not a key, okay, that is, we have not seen this sum previously, what we'll do, we will create a key value pair in this particular hash map. Okay, so how it is we are doing, see, this is the key, this is going to be the key, and this is going to be the value for it. Okay, now see, this is the most important part. I, okay, we obviously know, because I has sum of which has sum which is equal to 9, so we are returning I. But why this thing we are keeping? So see, what could happen is, in future maybe we will realize, for example, in this case 13, this is the only element whose, sum of key is equal to 4. Okay, no other elements have that particular sum of digits. Okay, for that reason what I'm doing is, I am storing I plus 1 with a negative sign. Why I'm doing that? See, as I mentioned, you will have to return -1. Okay, in the worst case, whenever a pair is not getting formed, you will have to return -1. So how to get that -1? This is how I'm going to get the -1. Okay, what I'm doing, I'm just doing I plus 1 and storing it with a negative sign. Now if you add this number and this number, okay, what will happen? It will return a -1. Okay, that is the basic idea here. So if you see, that is why if you add these two, you will get -1. Okay, and again example 2, if you see, basically here if you see the output is -1, because none of them are forming pairs. See, that is the reason why. See, 1, the sum of digit is 1. Okay, only number is 10. Okay, that's why we are storing in the negative version of that with the increment. Okay, it is my 11. Okay, similarly the sum of digit equal to 3 is only 12. Okay, there's no other pair, that's why I'm storing -13, which is 12 plus 1 with a negative sign. Okay, similarly the sum of digit equal to 10, there are only one digit, only one value. Okay, and the negative of that number with increment is -20. Same is the case for 5. Okay, the sum of digit equal to 5, there is only one element like this 14, and the negative version of that with increment is -15. Okay, as simple as that. So if you now take the sum of any one, see, the sum of these two, the sum of these two, the sum of these two, or the sum of these two, you will always get -1. Okay, that is the reason why I've chosen this way. Okay, as simple as that. Okay, the I plus 1 with a negative sign, right? Now if this case is not, that means we have seen that key previously also. Okay, we have seen that key previously also. What we'll do, I will just compare. See, now I will just compare with the zeroth element of this. Okay, see, there are two elements here, right? Zeroth element and the element number with index 1. Okay, so first I will compare with the with index number 0. Okay, see, among these two, see, always remember, among these two, zeroth element is supposed to be the highest element, and the index number 1 is going to be slightly smaller than that. Okay, so always. Okay, now I will just compare with index number 0. If it is greater than index number 0, then what we'll do, we will store I in index number 0, and the previous value in index number 0 will go to index number 1. Okay, again I will repeat, if I is greater than the index number 0 element, then I will be stored in index number 0, and the element which was previously occupied in index number 0 will go to index number 1. Okay, see here, the element which was in index number 0 previously will now go to index number 1, and this I will now go to index number 0. Okay, as you can see. Okay, as simple as that. Let us say if this case is not true, that means the I is not greater than the element present in index number 0. So then the only choice remaining is, we will see whether I is greater than index number 1 element or not. Okay, if that is the case, then we will just replace it with the index number 1 element. Okay, if this is also not the case, then we will not do anything, we will simply go to the next iteration. Okay, as simple as that. We'll just go to the next number. Okay, that is how we are going to do it. At last, what we'll do is, we'll start answer equal to -1. Why I am taking -1? Remember, you should not take it 0. If you take it 0, in the max, you will see, because in the worst case, what could happen? The answer is gonna -1. But if you have starting answer with 0, because of the max function, you will get 0 and not -1 as the answer. So either take -1 or any number less than -1. Okay, okay, not less than. Okay, even you can take less than -1 also. Let us say -2, -3. Those things also you should be able to take. Okay, you can take that also, right? Now what I'm doing, I will go to the map and I will only go to their values. Okay, I don't need the keys, I just need their values. So these are going to be their values. Okay, this whole list that you're seeing is going to be the values. Okay, yep. Among them, I will go and I will just take the sum. Okay, I will just take the sum and then I will compare it with the existing answer. If this is greater than the existing answer, then the answer will be updated. At last, after going through all this, we are returning the answer. Okay, let me quickly run this and show you. As you can see, this is clearing all the basic test cases. I've already segmented this and it is beating 99% of the test cases in terms of runtime. Okay, as simple as that. So yeah, this was my code. Okay, the only thing that, see, I can think of is, see, if you have tried in a brute force, what you would have done, see, what people will normally do is, they will create a list like that, not like this. They will create an empty list and they will keep appending whichever number has the same sum of digit. Okay, that is, I will say, a very this is not the efficient way to do it. Okay, see, it's very clear, we only need the maximum value. That is, for every sum of digit, we only need the biggest two numbers. Okay, we don't need the rest of the numbers. Okay, if you see the constraint, it is going to be in the range of 10 power 9. Okay, 10 power 5. Okay, that is 10 power 5 elements are going to come. Obviously it doesn't make sense to store all of them. Okay, for that reason I'm saying only store the one. Okay, for each sum of digit only store the highest two values. Okay, because only they will be contributing for the answer, otherwise they will not contribute for the answer. Okay, so yep, that is about my ideas and I have implemented this. And yeah, I will give this in their comment section. You can take this and try, add some more print statements and then go through it. If you have any, if you feel any other optimization can be done, please do let me know. I will also try the same. Okay, yeah, Finn, that was all for this video. If you have not learned that, I will say like please do learn it, because see, this all is about basic mathematics. In LeetCode we usually do not get questions which require much mathematics, but again, if you go to code forces and other platforms, you will be requiring maths a lot. Okay, believe me, you will require maths a lot sometimes. Even some good companies like Infosys and other stuff, they ask questions which are more of a mathematics. Okay, more on the side of the mathematics. So yep, you can practice that. But again, like if you're targeting fang level companies, they will be more focusing on the algorithm part. Okay, they will not be testing out too much on the mathematics part. But again, like these are very basic things. Okay, you should be knowing this, otherwise you like if your introverts know that you don't know this part, then that will create a very bad impression. Okay, as simple as that. So though these are not much relevant, but you are supposed to know this part. So yeah, that was all for this particular video. If you have any better way of doing it, please do let me know. We can also try further, but I as of now do not see like any other solution which is able to beat this particular thing. Okay, in the same programming language. So yeah, friends, that was all for this particular video. And if you like my efforts, please do subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.